Welcome to our physics lesson today. My name is Nicholas Okuthe. We want to proceed with the factors that affect melting point and boiling point. We have already looked at how pressure affects melting point, a process that we call regulation. So we want to look at the second factor and how it affects melting point, that is impurities. I've already said that impurities lower melting point of substances, and this is applied in humid areas during winter, in which salt is spread on roads and paths to prevent freezing. If in those polar regions where temperatures are normally very low, in the morning you wake up and you find the whole land, the whole compound is made of ice. All the water that were around now solidifies and the whole place is covered by ice. So this affects transport, especially on road surfaces when the ice is formed on the road. So how do they solve this? They simply do it by applying salt. They spread salt on the road surfaces so that whenever ice is trying to form, then it has to form at a slightly lower temperature, so it will be difficult for ice to form on the road surfaces. We look at how impurities affect boiling point, and we have also said that impurities raise the boiling point of substances, and that is why salted food cooks faster than unsalted one. Also, you've seen maybe somebody trying to prepare ugali, then asked to sprinkle some flour on the boiling water. Yeah, the reason is not to make it boil faster, but to make it boil at a slightly higher temperature. So that way, it gives higher chances of having the food that is the ugali that is ripe, that is well cooked. So there's a question, or there's an illustration here of showing how impurities affect boiling point. So we are having two setups here. One, we have distilled water, which is pure. Then another case, we have salt solution that is being heated. So when they're heated at the same rate, with the same quantity of heat, and within the same time, then it will be realized that the one that is having salt solution will boil at a slightly higher temperature. If probably the boiling point was around 78, then the pure water will boil at 78, but the salt solution may boil at even 80, 85, or something like that. So when the liquids are heated to boiling point, the boiling point of salt solution is observed to be higher than that of distilled water. This because impurities raise the boiling point of a liquid. We also look at how pressure affects boiling point. Increase in pressure or decrease in pressure lowers the boiling point, while increase in pressure raises the boiling point. That one I've talked about. And this is why food takes longer to cook at high altitudes than at low altitudes, because pressure at high altitudes is higher. Maybe trying to cook food on top of Mount Kenya, and one trying to cook food maybe in Mombasa, which is at sea level, then Mount Kenya, which is at a high altitude, it will take longer time to cook food, yeah, compared to somebody doing it in Mombasa. So how do we create a balance, or how do we correct this? This is now the reason why water in a sufuria closed with a lid boils faster than water in a sufuria closed with a lid boils faster than one that is open. Replace that word with open. The steam pressure in a closed sufuria is higher, and this raises the boiling point of water, making it to boil faster. So in high altitude areas, maybe if you want to prepare food faster, then it will be advisable that you cover it with the lid. If you can't cover it with the lid, then you cook using something we call pressure cooker. Yeah, so pressure cooker will be an application that we'll look at later. So we proceed to the next part of this topic called evaporation. And this evaporation, many times we confuse it with boiling. What is evaporation? Evaporation is simply a process by which a liquid changes to a gas. Yeah, and it occurs at all temperatures. So even if you put a basin of water inside a room, then the water molecules will be changing, or will be flying off from the surface of the liquid into the air. meaning they are getting converted to a gas. So that process is what we call evaporation. But remember, boiling is occurring at a constant temperature called boiling point. So we'll see the differences. Factors that affect evaporation are: 1. Temperature. The rate of temperature increases with the rate of evaporation increases with temperature, since increase in temperature increases the kinetic energy of the molecules, since and the surfaces molecules easily escape. You know, for the molecules of a liquid to move to the surface or to the atmosphere, meaning to change into gas, they have to escape. Yeah, so there must be that kind of energy that they need to make them move or break away from the cohesive forces that hold them together. So when you increase the temperature, you increase the kinetic energy of the molecules, and when you increase the kinetic energy of the molecules, they will tend to now escape from the surface faster. So it is that is why it's very easy to dry clothes, or clothes to dry faster when the temperatures are higher than when the temperatures are low. For example, during the day when the temperatures are high, clothes dry faster than in the morning when the temperatures are slightly low. Number 2 is drought. Drought is also the same as wind. So wind increases the rate of evaporation. Why? Because it sweeps away the evaporating molecules, clearing the way for more molecules to escape. Yeah, so when wind flows, then it sweeps the molecules that have already escaped from the surface, it sweeps them away. In the process, it leaves some partial vacuum or space for more molecules to come and accumulate. So this is the same reason why clothes dry faster on a windy day compared to when it is calm. Surface area. The surface area exposed for evaporation will affect evaporation, and evaporation tends to be higher when the surface area is large. Like in this case, we have two basins. One has a larger surface area and another one has a smaller surface area. So evaporation will tend to take place more in setup A than in setup B, because more molecules are now exposed. When the surface area is large, then more molecules are exposed for evaporation to take place. So this now gives them more, or makes it easy for them to escape to the surrounding. Number 4 is humidity. Humidity is the amount of air in this atmosphere, and increase in humidity lowers the rate of evaporation. When there are more water molecules in the atmosphere, then it means the water molecules or the liquid molecules have no space in the atmosphere to occupy. So at the end of the day, they will tend to remain within the container. So increase in humidity lowers the rate of evaporation, and that's the same reason why clothes take longer to dry on a humid day. What are some of the effects of evaporation that we interact with on our daily basis? Number 1 is one feels cold when methylated spirit is applied at the back of his arm, or even on your head after shaving. After shaving, when maybe the barber puts some methylated spirits on your head, then you feel some coldness. Also, when you take maybe methylated spirit and you pour it at the back of your arm, then you feel some coldness after some time. Why? The spirit, once it is in contact with your skin, absorbs latent heat of vaporization from your skin. And after absorbing, spirit being a very volatile liquid, it will evaporate, but with the latent heat of vaporization from your body with it. Yeah, so that's what causes the skin to appear or to have that colder feeling when methylated spirit is applied on it. Number 2, thin layer of frost forms around the outside of a test tube when air is blown through methylated spirit in the tube. When you have methylated spirit in the tube, or another substance, we call it ether, yeah. Then when you blow air on the inside of that tube, then you will see some frost or some smoky thing around the test tube. Why? It is because the evaporating spirit obtains latent heat of vaporization from the walls of the tube, and the process creating a cooling effect. This is also applied, I don't know whether I have it here, but I don't have it here, but it's also applied in our homes where we keep cold water in some pot. Yeah, the pot that carries drinking water. When you look at that pot, at the back of the pot, you always have some cold liquid, and also the pot is able to keep the water cold as a freezer or even a fridge. Why? When you pour water into that container or that pot, then the pot normally is normally porous, so it's able to absorb, the water is able to absorb latent heat of vaporization from the pot as some seeps out. So the water that seeps out, which sometimes you find the back of the pot as cold, will have a lower temperature than slightly the one we have inside the pot. So all these are an application of evaporation. So the table there has given us differences between boiling and evaporation. Maybe briefly, evaporation takes place at all temperature, boiling takes place at a fixed temperature, which is the boiling point. Evaporation takes place on the surface of the liquid only, boiling takes place throughout the liquid. Then decrease in pressure increases evaporation, but decrease in pressure normally lowers the boiling point. So that's all we have for today. I know in future we'll be able to look at the remaining part of it. Thank you.